Hey guys, welcome to your first lesson. So kind of as I explained in class, the way it's going to work is these videos will get you the foundational knowledge. I'll go through a lot of the definitions in here. And then in class, we'll kind of debrief on those definitions and we'll go through the examples that are in the notes, as well as some additional kind of examples to help further your knowledge and understand the topic that we're doing. So it's very, very important that you watch these videos, you write down what I'm writing as we go through them, and then leave the stuff that's blank for in class, and we'll go through that stuff kind of in class together. You'll notice that there's also page numbers to read, as well as the section numbers. I encourage you to do that. It's not mandatory, but if you're a little unsure of something, you can head to the book and read through those pages to see some more examples and kind of see how the book lays things out for you. So let's get going here. So our first blank, statistics, which is the class you're taking, is the science of data, okay? Our next blank, data analysis, is the process spelled that wrong. Is the process of organizing, displaying, summarizing, and asking questions about data. Statistics and data analysis is so important in today's society, and understanding and being a knowledgeable person of this stuff is more important than ever with what we're dealing with the pandemic, elections, everything. So it's really important, and now, like I said, more than ever, it's a great time to be learning about this stuff. So what are individuals? An individual is an object described in a set of data. And individuals can be people, they can be animals, they can be things, they can be all kinds of things. Okay? So don't just think of it as, sorry, my handwriting's a little sloppy. Don't just think of it as it has to be human beings. It can be all types of different things. Now, the variable is the thing that you're measuring, okay? The fancy definition of a variable is any characteristic, I'm going to simplify it a little bit, any characteristic of an individual. So for example, we could be measuring people's heights, and that would be our variable. We could be measuring their favorite color or asking them their favorite color. We could be asking them what town they live in. We could be asking them their GPA. That thing, that characteristic of an individual, or that thing that you're measuring, or that thing that you're asking them about, is your variable. So we have two types of variables. We have categorical variables, which places individuals into categories. And then we have quantitative variables, which take on numerical values. And in class, we'll talk about and we'll list out some different things, some different types of categorical and quantitative variables. In your head, you can be thinking categorical variables: color, favorite subject, favorite TV show, what political party you're affiliated with. Quantitative, you could be thinking things like height, GPA, age, test score, things like that. And we'll list some more out in class. So a variable in general takes on many different values. What we're interested in is how often a variable takes on each variable, or takes on each value. So for example, we want to know how many people have blue as their favorite color. How many people got a perfect score on their SAT? Okay? That's what statistics is all about. you'll hear lots of times in this course something like describe the distribution or compare the distributions. So what is a distribution? A distribution tells us what values a variable or the variable takes on, as well as how often it takes on those values. So again, like I said, you'll hear things like describe the distribution, compare the distribution all the time in this class. When we're talking about exploring data or looking at data in general, you want to start with each variable. And after we do that, we're going to be looking at the relationships between those variables. Start with a graph, and we'll see lots of graphs in this class and analyzing them. And then later on, we'll look at the numerical summaries, comparing quartiles and averages and means and things like that. So this example, we're going to go through in class together. If you want to take a look at it ahead of time, feel free, but we'll go through it in class, as well as to check your understanding. So that's really just an introductory lesson. 1.1 is our first true lesson, and it deals with categorical data. So we kind of hinted at categorical data before, but categorical data places individuals into one of several groups or categories. So we know quantitative data, it takes on numerical values. Categorical we can place into categories, like the format of radio stations. So if we look here, we've got adult contemporary, adult standards, contemporary hit, country, and so on and so forth. On the left-hand side, what you see, oops, scroll up a little bit, sorry. On the left-hand side, what you see is you see what's called a frequency table. A frequency table shows the actual counts, meaning how many stations are adult contemporary and so on and so forth. This format, by the way, is our variable. That's what we're asking or we're measuring. Okay, and these in here are our counts. On the right-hand side, what you have is you have a relative frequency table. What's the difference? This deals with percentages. So instead of showing the actual counts, we're showing the percentages. Why would we care about percentages? Well, it's going to become really important when you're asked to compare distributions. Because when you're asked to compare distributions, you don't want to compare the counts. You want to compare the percentages. Because what if, for, say, we're looking at radio stations in New York compared to Dallas, Texas. And maybe there's 15,000 in New York and only 11,000 in Dallas, Texas. Well, we don't want to compare the counts because there's not an even number of counts. But if we compare the percentages, we can compare the percentages in an apples-to-apples comparison. So you always want to shift into percentages when you're dealing with any type of comparison. So instead of looking at a table, which is kind of tough to look at, it might be easier to analyze a distribution with a bar graph or a pie chart, which are the two types of graphs that you can use for categorical data. So if you look down here, what you see is you see two different types of graphs. On the left is a bar chart, and on the right is a pie chart. Okay, both can be used for categorical data. Bar graphs compare several quantities, and I know you've seen them before, by comparing the heights of the bars that represent those categories. However, our eyes are always going to react to the areas, which include the width as well. So it's important when you're doing this to make sure that the bars are equally wide. Okay, make sure that your bars are not of different widths. That's a common way to lead to a misleading graph, which you're going to see in the example below, which we'll see in class. So two things to keep in mind. You want to make sure that you're watching the scales. Okay, the scales can lead to something that's misleading in our graphs, as well as to beware of pictographs. Pictographs look pretty, but they're oftentimes misleading. And you'll see when we go through this example in class of ways that we can have a misleading graph. Let's continue on. So when a data set involves two categorical variables, we begin by examining the counts or percents in various categories for one of the variables. We have what's called, and you'll see this lots of times in this course, a two-way table. A two-way table describes two categorical variables, organizing counts according to a row variable and a column variable. So basically in a two-way table, we're just measuring two different variables. We could be measuring gender versus eye color. We could be measuring town versus political party. Okay, lots of different things that we could use. In this particular example, what we're looking at is measuring, asking a survey of 4,826 randomly selected young adults. What do you think your chances that you will become rich? Okay, and we ask females. That's our one variable, and then the chance that you think you're going to be rich as our other variable. All right. And again, we'll look at this example a little bit more in depth in class. Within that, we have what's called the marginal distribution. Of one of the categorical variables is the distribution of values of that variable among all individuals described by the table. That's a little bit confusing of a definition, so the easy way to think of it is it's going to be a row or a column total divided by the overall total. Percents are often more informative than counts, especially, like I said, when you're comparing groups of different sizes. So how do you look at a marginal distribution? You want to use the data in the table to calculate the marginal distribution in percentages of the row or column total, like I was saying. And then you can make a graph to display your marginal distributions. And again, we'll look at an example of looking at a marginal distribution in class. If you want to take a look and try and do it ahead of time, feel free. But we'll look at this in class. Final major area that we have to talk about is dealing with a conditional distribution. So we have marginal distributions and conditional. People often confuse these. So while a marginal distribution was a row or a column total over your overall total, a conditional distribution is going to be an individual cell in your two-way table over a row or a column total. So conditional distribution of a variable describes the values of that variable among individuals who have a specific value of another variable. So for example, we might be looking, when we're talking about a conditional distribution, of the males, what percentage said almost none, or what percentage said that they were almost certain that they would get rich. So we put a condition on, we're only talking about the males. As opposed to in a marginal distribution, it might be saying something like, what percentage of the overall total think that they have a 50-50 chance of getting rich? That's marginal, a row total over our overall total, as opposed to conditional, which would be only of the males or only of the females. Or of the 50-50 chance, what percentage are male? Those are conditional distributions. So to examine or compare conditional distributions, you first want to select the rows or columns of interest. After that, use the data to calculate the conditional distributions. And then we're going to be using either a side-by-side or a segmented bar chart to compare those distributions. All right, there's an example that follows, which we'll do in class, but you've got the foundations of section 1.1. Hopefully you've got all that down. You can review it as many times as you like. And in class, we'll go through these examples and kind of explore a little bit further on this first section. Good luck, guys, and see you in class.